Hello everyone, right, it's a quick tutorial on how to draw a triglycerides. So triglyceride is made from two different parts, two different molecules. So we've got glycerol, and that glycerol has got 1, 2, 3 fatty acids connected to it. All right, and that's why it's called a triglyceride. So it's got those 3 fatty acids. So we're going to draw this in more detail. So the glycerol is quite easy. We're going to do 1, 2, 3 carbons, and those carbons all need to have 4 bonds going around them. These little sticks I'm drawing. So this one here has already got 1. So I'll do 2, 3, 4. This one's got 1, 2, 3. It's already got that one, 4. This one's got 1, 2, 3, 4. Making sure carbon's always got 4 projections coming out of it. Top and the bottom we have hydrogens, and the left hand side we also have hydrogens. And then the 3 remaining bonds on the right, we're going to add hydroxyl groups. And that is glycerol, so we need to remember that. Let's draw a fatty acid now. So fatty acid is, again, it's a hydroxyl group connected to a carbon. And that carbon's also got a double bond connecting to oxygen. And this is called, what I've drawn here, this is a carboxyl group. Let's draw the rest of it. So we've got CH2N, CH3. I'll explain to you what this means. It's not that difficult. Okay, so if you remember from looking at glycosidic bonds, how condensation reactions form, you'll hopefully remember that it's the interaction of hydroxyl groups. So you can see here, we've got this H and this OH. They're going to interact to form water. So that's going to leave behind a carbon and this oxygen here. So a new bond is going to form between that oxygen and that carbon. And we call this here an ester bond. So if I draw fatty acid just by itself, just so you can remember what's happening. So we've got a carbon with the OH group plus the oxygen. So that's a carboxyl group. We've done this. It's COOH. And then we're going to just add the rest of it. This is the tail. This CH2N and CH3 is representing the actual length of the tail. So again, this part here is going to be interacting with this here. So get rid of that, and now we can draw another one. So there's our carbon. There it is there. It's this one here I'm connecting to. It needs to have the double bond oxygen. CH2 in brackets. N CH3. Let's do it again for the last one. Carbon again. Double bond oxygen. Brackets CH2N CH3. Okay, so let's have a look what this means here and this here. So another way you can draw it, what I'll do is I'll just rub this bottom one out. Let's do it again. I'm going to do it a different way. So we've got our the oxygen from the glycerol is still left behind. It's the oxygen bridge. There's the carbon double bond. And we're going to draw it a different way. Rather than just writing CH2N, CH3, I'm going to do it this way. So The fatty acid tail is just a chain of it's just a hydrocarbon tail. So it's just loads of carbons, and those carbons are going to be surrounded by hydrogens. And that tail can be a different length. I could make it 3 carbons long, I could make it 4, I could make it 5, I could make it 6. And that's what this N represents. It's representing that CH2, notice this C has only got 2 hydrogens attached to it. So is this one. So it's saying that the carbons with 2 hydrogens attached can be different lengths. And that's what N represents. So this CH2 chain, it will make it 5 carbons long. And then at the end it says CH3, and that's just representing the very last carbon, because this carbon here has 1, 2, and 3. So for doing triglycerides, we have to be able to draw glycerol. We need to be able to draw fatty acids. We have to show how an ester bond forms. And that's called esterification. We need to know about the carboxyl group. Which was the COOH. That was the part here on the fatty acid. And how that's the bit that's interacting with the hydroxyl group of the glycerol. So this is a case of just practicing. Give it 5-6 goes. You'll know this easily. So yeah, really making sure you practice this. See you later.